My dear students, Namaste, good morning to you all, and also welcome to another session of online mathematics class. In the previous session, we have learned how to calculate the area of a triangle by using determinants. Hope you have revised well. And in today's session, we shall discuss the minors and the cofactors of a determinant. Let's move on to the topic. Let's begin the session with minors and cofactors. In the previous classes, we have learned how to calculate the value of a determinant. A determinant of order 3 by 3 matrix A is equal to matrix A11, A12, A13, A21, A22, A23, A31, A32, A33 is given by determinant A is equal to determinant of A11, A12, A13, A21, A22, A23, A31, A32 and A33. Here we know how to calculate or how to expand this determinant along row 1. The expansion is determinant A is equal to A11, that is the first element of the determinant, A11 into minus 1 the whole power 1 plus 1. This 1 plus 1 is first row first element and first column first element. First one is row value and the second one is column value into, since we have taken A11, we have eliminated the first row and the first column. The balance elements we have written as another determinant, that is A22, A23, A32 and A33, plus the second element we have taken, that is A12 into minus 1 the whole power, the row value and the column value, that is 1 plus 2 into determinant. Since we have taken A12, that particular row and the column is eliminated. The balance elements A21, A23, A31 and A33 we have taken and we have written here as determinant, plus A13 into minus 1 the whole power 1 plus 3 row value plus the column value into, since we have taken A13, that particular row and column is eliminated and the balance A21, A22, A31 and A32 we have taken and written here as determinant. And here these determinants, that is A11, while taking A11, that column and row is eliminated. The balance elements, that is A22, A23, A32, A33, and here A12 is taken and that particular column and row is eliminated. The balance determinant is written here and the last step in A13 we have eliminated that particular row and column. We have written here the balance elements as determinants, and these three determinants are called the minors. The minors, A11 minor is this term and A12 minor is this determinant and A13 minor is this determinant. Once again in the expansion, when you check the elements along with minus 1 the whole power row value plus column value into the determinant, and here also minus 1 the whole power row value plus column value along with the determinant, and here also minus 1 the whole power row value plus column value and the determinant. These terms together we called the cofactors of A11, A12 and A13. Through the previous example, we have learned how to write the minors and the cofactors of each element of a determinant. Now let's define these minors and cofactors. Minor of an element Aij of a determinant is the determinant obtained by deleting its ith row and jth column in which element Aij lies. For example, if we are taking A11, that is the first element in the first row and also in the first column. So if we take A11, how we have to write the minor of A11 is, we have to avoid the first row and the first column, then the balance 4 elements we have to collect and we have to write as a determinant. So that is the minor of the element A11. So in general, if you say minor of an element Aij of a determinant is the determinant obtained by deleting its ith row and jth column. Means if I have taken A11th element, I have to remove first row element and first column element. That's what it is saying by deleting its ith row and jth column in which element aij lies. So minor of an element aij is denoted by mij. M stands for minor, so capital Mij. Next, the cofactor of an element aij is denoted by capital Aij, is defined by aij is equal to minus 1 the whole power I plus j into mij. Mij is the minor of that particular element, that is aij, where mij is the minor of aij. For example, if you want to take the cofactor of a11, first we have to write minus 1 the whole power 1 plus 1 into, we have to write the minor of a11, means we have to delete the first row and the first column, then the balance 4 elements we have to write it as a determinant. So together, that is minus 1 the whole power 1 plus 1 into the minor of a11, together we call it as the cofactor of the element aij. So let's take an example. Here find the minor and cofactor of element 6 in the determinant. So here element 6 is in the second row and the third element, second row third element, that is 6. So how to write? That is, since 6 lies in the second row and third column, its minor is M23 is given by M23 is equal to, since we have taken 6, that particular row and that particular column is deleted, and then we have to write the balance 4 elements, that is 1, 2, 7 and 8. So the minor of the element is M23 equal to determinant 1, 2, 7, 8. That is equal to, when we calculate, multiply 1 into 8, that is 8, minus 7 into 2, that is equal to 14. So 8 minus 14 is equal to minus 6. So the minor of the element M23 is equal to minus 6, or the minor of the element 6 is equal to minus 6. Next, to calculate the cofactor of A23, that is equal to capital A23, that is equal to minus 1 the whole power row value plus column value, that is row is 2, column is 3, so 2 plus 3 into minor of 23, that is minus 1 the whole power 2 plus 3 into, we have calculated M23 value, that is M23 is minus 6. So minus 1 the whole power 2 plus 3 into minus 6, that is equal to minus 1 the whole power 5. 2 plus 3 is 5 into minus 6, that is equal to 6. That is the answer. Next, we shall discuss problems from exercise 4.4. The first question is, write minors and cofactors of the elements of the following determinants. The first question is determinant 2, minus 4, 0, 3. Here we have to take each element and we have to write the minors and cofactors. Means we have to take first element 2 and then we have to write the minor and cofactor. And next we have to take minus 4, then we have to write the minor and cofactor. Same ways we have to take 0 as well as 3 and then we have to write the minors and cofactors. So since it is a very simple question, you will do it as homework. And the next question is question number 2, that is determinant A, C, B, D. So let's recall how to write the minor. So the minor of an element Aij is Mij. So here first element, that is M11, that is minor of element A11 is here. This element, if you take A, the first row and the first column is eliminated and the balance we have only one element, that is D. So minor of an element A11 is equal to D. Next, M12, that means this is the element, first row second element, that is M12 is equal to minor of element A12. A12 is C, that row and that column is eliminated and the balance element, that is B, is the minor of M12. Next we have to take the third element, that is M21, minor of element A21. A21, the element is here B, second row first element. That row and column is eliminated, the balance is C. So the minor of element A21 is equal to C. And next one more element is left, that is M22, that is minor of an element A22. So A22 is here D. If you take D, that row and column is eliminated and the balance element is A. So A is the minor of the element A22. Then let's recall the cofactor. So cofactor of Aij is minus 1 the whole power, the row value plus column value into its minor. So let's write A11. A11 means the cofactor of the first element, that is minus 1 the whole power, row value plus column value into minor of 1 1. That is equal to minus 1 the whole power 1 plus 1. 1 plus 1 is 2 and M11 we have already calculated, that is D. So minus 1 the whole power 2 into D, that is equal to D. So here minus 1 the whole square is plus 1. So the value sign is not changing, it is D. Next A12, that is the cofactor of A12, cofactor of C. That is minus 1 the whole power 1 plus 2, row value plus column value. Here first row second element, that is 1 plus 2 into minor of 1 2. Minor of 1 2 we have calculated, that is B. That is minus 1 the whole power 1 plus 2. 1 plus 2 is 3 into B. That is minus 1 the whole power 3 is minus 1. Minus 1 into B is minus B. Next, the cofactor of element A21, that is minus 1 the whole power 2 plus 1 into minor of 21. Minor of 21 we have calculated, that is C. So minus 1 the whole power 2 plus 1. 2 plus 1 is 3 into C. So minus 1 the whole power 3 is minus 1. So minus 1 into C is minus C. And the last term, that is the cofactor of A22, is equal to minus 1 the whole power 2 plus 2 into M22, minor of 22. So minor of 22 is we have calculated, that is A. So minus 1 the whole power 4 into A. Since minus 1 the whole power 4 is plus 1 into A is A. Next we shall discuss question number 2 of exercise 4.4. The first question is determinant 1 0 0 0 1 0 0 0 1. It is a 3 by 3 determinant, and now you know how to calculate the minors and cofactors of each and every element of a determinant, and this question you will do it as homework. And question number 2, determinant 1 0 4 3 5 minus 1 0 1 2. So the given determinant is 1 0 4 3 5 minus 1 0 1 2. So we have to write the minor of first element, that is minor of A11, that is equal to determinant. First element, if you take that row and column is deleted, balance 5 minus 1 1 2. That is written here as determinant. Calculate the value of that determinant. 5 into 2 10 minus 1 into minus 1 is minus 1. So minus into minus 1, that is plus 1. So 10 plus 1, that is equal to 11. Next M12, that is a minor of the element A12. A12 is this element, that row and column is gone. Balance elements 3 minus 1 0 2. Calculate the value of the determinant, that is 3 into 2 6, 0 into minus 1 0. 6 minus 0, that is equal to 6. Next M13, that is minor of A13. A13 is this one 4. So that row column is eliminated. 3 5 0 1 are the elements, that is written here as determinant. Calculate the value of the determinant, that is 3 into 1 3, 0 into 5 0. So 3 minus 0, that is equal to 3. Next M21, that is minor of A21, second row first element, that is 3. That particular row and column is gone, the balance 0 4 1 2, that is written here, that is 0 minus 4, that is equal to minus 4. Next element, that is M22, minor of A22. So this is the element, 5 is the element, that row and column is gone, 1 4 0 2 are the elements. Calculate the value of the determinant. 1 into 2, that is 2. 0 into 4, that is equal to 0. 2 minus 0, that is equal to 2. Next M23, minor of A23. A23 is this one, minus 1. So that particular row column is gone. 1 0 0 1. These are the elements that we have written here as determinant. Then calculate its value. 1 into 1, that is 1. 0 into 0, that is equal to 0. 1 minus 0, that is equal to 1. Next, M31, that is minor of element A31. A31 is this one. Third row first element, that is 0. That row column is gone. Balance elements 0, 4, 5, minus 1. That is written here. Calculate the value of this determinant. 0 into minus 1 is 0. 5 into 4 is 20. So 0 minus 20, that is equal to minus 20. Next element, that is M32, minor of A32. So third row second element, that is 1. Delete that row and column. Balance 1, 4, 3, minus 1. It is written here as determinant. 1 into minus 1, that is minus 1, minus 4 into 3, that is 12. Minus 1 minus 12, that is equal to minus 13. Next element, that is M33, that is the minor of A33. A33 is 2 here. That row column is gone. 1, 0, 3, 5. These are the elements. To calculate the value of the determinant, 1 into 5, that is 5. 3 into 0, that is equal to 0. So 5 minus 0, that is equal to 5. So the minus of all the elements are written here. Next, cofactor of A11. Cofactor of A11 is equal to minus 1 the whole power row value plus column value into its minor. So here minus 1 the whole power 1 plus 1 into M11. So M11 is 11 here. Minus 1 the whole square, that is plus 1. Plus 1 into 11, that is equal to 11. Next is A12, that is cofactor of A12, that is equal to minus 1 the whole power 1 plus 2. Row value is 1, column value is 2. 1 plus 2 into M22. So here M22 is 6. Minus 1 the whole power 3 is minus 1. Minus 1 into 6 is minus 6. Next is A13, that is cofactor of A13. That is equal to minus 1 the whole power row value is 1 plus column value is 3. So 1 plus 3 into M13. M13 is here 3. So minus 1 the whole power 4 is plus 1 into 3, that is equal to 3. Next is A21, that is cofactor of A21, that is equal to minus 1 the whole power 2 plus 1. Row value is 2, column value is 1 into M21. M21 is minus 4 here. So minus 1 the whole power 3, that is minus 1. Minus 1 into minus 4. Two minuses will together will be a plus. So plus 4 is the answer. Next is A22, that is cofactor of A22. Minus 1 the whole power row value is 2, column value is also 2 into M22. M22 here we have 2. So minus 1 the whole power 4, that is plus 1 into 2, that is equal to 2. Next is cofactor of A23, that is equal to minus 1 the whole power row value is 2 plus column value is 3. So 2 plus 3 is 5. Minus 1 the whole power 5 is minus 1 into M23. M23 we are having 1. So minus 1 into 1, that is equal to minus 1. Next is A31, that is cofactor of A31 equal to minus 1 the whole power 3 plus 1. Third row first element 3 plus 1 into M31. M31 we have minus 20. So minus 1 the whole power 4 is positive value, that is plus 1 into minus 20, that is equal to minus 20 is the final answer. Next is A32, that is minus 1 the whole power 3 plus 2. Third row second element 3 plus 2 into M32. Here minus 1 the whole power 5 is minus 1 into M32. M32 is minus 13. So minus 1 into minus 13 is plus 13. And the last element, that is A33, is equal to cofactor of A33, that is equal to minus 1 the whole power row value is 3, column value is 3. So minus 1 the whole power 3 plus 3. 3 plus 3 is 6. Minus 1 the whole power 6 is plus 1 into M33. M33 we have 5 here. So 1 into 5, that is equal to 5. Now we have calculated the minors and cofactors of all the elements of the given determinant. Next, we shall discuss question number 3 of exercise 4.4. The question is, using cofactors of elements of second row, evaluate delta is equal to determinant 538, 201, 123. Here we are asked to calculate the value of this determinant by using the cofactors of elements of second row. Previously, we have done this question as expansion along second row. So here we are asked to do cofactors of elements of second row we have to use and calculate the value of this determinant. The given determinant is determinant 538201123. Here cofactor of 821 second row first element, that is 2, that is equal to minus 1 the whole power 2 plus 1, row value is 2, column value is 1, into m21 minor of 21. Here minor we are not calculating separately, since it is a simple question we will do it together. So m21 means we have to eliminate that particular row and column, that is second row and the first column. The balance elements are 3, 8, 2, 3. So here 3 into 3 is 9, 2 into 8 is 16. So here 9 minus 16, 9 minus 16 is 7. So minus 7, 9 minus 16 is minus 7. So minus 1 the whole power 2 plus 1, that is 3. That is minus 1 the whole power 3 is minus 1. Minus 1 into minus 7. Minus 1 into minus 7 is plus 7. Those who feel difficulty to calculate, you can write the entire step and you can do it. Next is A22, that is cofactor of A22. Second row, second element, that is 0 here. That row column is eliminated. So 5 into 3, that is 15, minus 1 into 8. So 15 minus 8, that is 7. Minus 1 the whole power 2 plus 2 is 4. So it is minus 1 the whole power 4 plus 1 into 7, that is equal to 7. Once again I am repeating, if you feel any difficulty, write and calculate minus separate and then do it. So for easy calculations, this is the best way. You can save the time when you are going for examinations. Next is A23, that is cofactor of A23 is equal to minus 1 the whole power 2 plus 3. 2 plus 3 is 5. Minus 1 the whole power 5 is minus 1. Then M23, minor of 23. Minor of 23 means this is the element. That row column is gone. 5 into 2. 5 into 2 is 10. 1 into 3 is 3. So 10 minus 3 is 7. Here minus 1 into 7. Minus 1 into 7 is minus 7. Next we can calculate the value of this determinant, that is delta is equal to A21 into, this is the element A21 into cofactor of A21 plus element A22 into cofactor of A22 plus element A23 into cofactor of A23. This is simply same as the expansion along second row we have done before, but here we are using minus and cofactors, that is the difference. So that is equal to A21. A21 the element is 2. 2 into the cofactor of A21, that is here it is calculated 7. So 2 into 7 plus A22 element, that is A22 element is 0. 0 into cofactor of A22. Cofactor of A22 is 7. So 0 into 7 plus A23. A23 element is 1. 1 into cofactor of A23. Cofactor of A23 is minus 7. So 1 into minus 7. You go for the calculation, that is 2 into 7, 14. 0 into 7, 0. 1 into minus 7 is minus 7. So finally 14 minus 7 we will get, that is equal to 7. So that is the value of the given determinant. Next we shall discuss question number 4 of exercise 4.4. The question is, using cofactors of elements of third column, evaluate determinant 1 x y z, 1 y z x, 1 z x y. So here we are asked to calculate the value of this determinant by using the cofactors of third column, means this column. These elements we have to, cofactors of these elements we have to use to calculate the value of this determinant. So the given determinant is determinant 1 x y z, 1 y z x, 1 z x y. Cofactor of the element A13, that is equal to A13th element is this one. So minus 1 the whole power 1 plus 3. Row value is 1, column value is 3. So since this is the element, that row and column is eliminated. 1 y, 1 z. That is the balanced determinant. So that is equal to minus 1 the whole power 1 plus 3 is 4 into 1 into z is z, 1 into y is y. Minus 1 the whole power 4 is plus 4 plus, sorry, plus 1 into z minus y is z minus y. Next is a23, that is equal to cofactor of element a23, that is equal to minus 1 the whole power 2 plus 3 into, so this is the element, that row column is gone, the balance 1x and 1z. So 1x 1z is written here as determinant, that is equal to minus 1 the whole power 2 plus 3, that is equal to 5 into 1 into z. 1 into z is z, 1 into x is x, so z minus x. Minus 1 the whole power 5 is minus 1, so minus 1 when you multiply with z minus x, so minus x will be plus x and plus z will be minus z. So we can arrange it in order, we can write it as x minus z. Next is a33, that is cofactor of element a33. A33 element is xy, that is equal to minus 1 the whole power 3 plus 3 into, that particular row and column is removed and 1x 1y, that is the elements we have written here as determinant, that is equal to minus 1 the whole power 3 plus 3, that is equal to 6 minus 1 the whole power 6 into 1 into y. 1 into y is y, 1 into x is x, so y minus x. Since minus 1 the whole power 6 is plus 1 into y minus x is y minus x. Next, delta is equal to a13 into the cofactor of a13 plus a23 element into cofactor of a23 and a33 element into cofactor of a33. This is the expansion along third column, that is equal to a13. A13 is here yz, so yz into cofactor of a13 is taken z minus y, that is written here, plus a23. A23 is zx. A23 is this one, zx into cofactor of a23. Cofactor of a23 is x minus y. So zx into x minus z. So zx into x minus z plus third element, that is xy into cofactor of a33. Cofactor of a33 is y minus x. So xy into y minus x. Then we shall remove it, that is yz into z, that is yz square. Then yz into y, that is y square z, plus zx into x, that is x square z. Then plus into minus, that is minus zx into z, that is z square x or xz square, plus xy into y, that is xy square, plus into minus, that is minus x into x, x square into y, that is x square y. Next we shall regroup it and take some common factors, that is while regrouping x square z and y square z, taking together x square z and y square z. So x square z minus y square z plus yz square and xz square is taking together. So yz square minus xz square plus xy square minus x square y is keeping together. So again, once again I will explain about the regrouping, that is x square z and y square z together. So x square z minus y square z plus yz square and minus xz square are taking together, plus the balance two terms just taking together. Then take common factors. In these two, z is common, then z into balance is x square minus y square, plus in these two z square is common, take out, then y minus x is the balance, and in these two xy is common, take out xy into, in the first time balance y is there, in the second time balance x is there. Then by using a square minus b square identity, we can expand this one, that is z into x square minus y square, we can write it as x minus y into x plus y, plus the balance remains same, z square into y minus x plus xy into y minus x. Next, x in this all the terms, when you check, there is x minus y is common. Here x minus y is there, here y minus x is there, of course we can take x minus y from here. Here also y minus x is there, we can take x minus y outside. So x minus y outside, if I take the first term, there is balance, that is z into x plus y is the balance. So I have removed that also. Z into x, that is zx. The next is z into y, that is zy. Minus, in this term y minus x was there and I have taken x minus y outside. So one minus is left here. That minus will come here as minus z square. Here also y minus x was there. I have taken x minus y outside. So minus is the balance. Minus into xy is minus xy. Once again I will explain this part. That is, here x minus y I am taking common. So x minus y is outside. In the first part, x minus y going means z and x plus y was the balance. I have removed the bracket, that is z into x zx, z into y zy. That is what it is written here, zx plus zy. And here y minus x was there. I have taken x minus y outside. So minus 1 was the balance. So minus 1 come here as minus 1, sorry, minus z square. Here in the third time also y minus x was there, but I have taken x minus y outside. So minus 1 is the balance. Minus 1, when it is joining with xy, we will get it as minus xy. That is equal to x minus y into, so here zx plus zy minus z square minus xy. So here also I am regrouping, that is zx and z square if I take together and z outside if I take. So the first term and the third term, that is zx and minus z square. From these two I am taking z outside, that is z into here x balance and here one minus z balance, that is written here. Plus in the remaining two terms there is y is common. Here is zy and minus xy. In these two y is common. I am taking out, that is y into here z balance, here minus x balance. So z minus x. Once again, first and third I am taking, and from there I am taking z outside. So z outside taking means here x balance and here minus z balance. So z into x minus z. Plus in the second and fourth there is y common. I have taken y outside, then balance z minus x, that is written here. Next, here x minus z is there, here z minus x is there. We can take common, that is z minus x. X minus y into z minus x if I take outside, here x minus z was there, but I have taken z minus x as common. So there is a minus left behind here, that minus will come along with z. So minus z, and in these two z minus x was there, z minus x is outside, balance is y. Just to rearrange it, that is x minus y into y minus z into z minus x. So x minus y as it is. Here z minus x was there, z minus x it is written here, and this z minus z plus y we are writing as y minus z, just arranging it in order. So that is the answer. Therefore, delta, the value of the given determinant is x minus y into y minus z into z minus x. So this question, when you go through this entire portion, so you may feel it is difficult because of algebraic expansions and all. So you can try it some other format also, it's not a problem. Which one you feel it is easy, that method you can follow it. Next, question number 5 of exercise 4.4, that is, for the matrices A and B, verify that AB the whole transpose is equal to B transpose A transpose, where A is equal to a column matrix is given to you, that is 1 minus 4 3, and B is equal to a row matrix is given to you minus 1 2 1. And the next question, A is equal to again a column matrix 0 1 2, and B is equal to another row matrix, that is 1 5 7. This one we have revised transpose of a matrix several times, and this question you will do it as homework. My dear students, in today's session we have learned the minors and cofactors of a determinant. Comparatively, it is a very easy topic and easy to learn as well. Only question number 4 you have to take special attention, because there are some algebraic expressions we need to expand and arrange it. So hope it is clear for you all, and thank you for watching.